Welcome to the course Mathematical Foundations of Computer Science. So, Unit 5 is graph theory in our course. So, we will try to study the different concepts in graph theory and solve some problems which will help us in solving the other problems of computer science. This is one very important concept, though it is a branch of mathematics. Graph theory is a branch of mathematics. It has lot of relationship with computer science because we have a graph data structure. Inspired from this graph theory concept, we have a graph data structure, okay, so which helps us in solving lot of problems, right. So, why do we have to study graph theory? What kind of problems can we solve using this graph theory, okay, mathematically or maybe using the computer science concept or the data structure, right. Assume, let us say an example to understand this. Assume there is a new, you are constructing a new campus, you are constructing a new university, or maybe we want to have one extended branch in some other location, right. In that case, you have lot of space, maybe this length is almost 3 kilometers and this breadth of the institute is almost 2 kilometers. Okay. So, we have a very huge space, maybe some 1500 acres of land, such a huge space I have. So, what we try to do to effectively occupy the place, we will try to construct buildings at different locations like this, at some far locations. If you see our own university, we have buildings at different places, hostel range is separate, quarters are separate, buildings are separate, academic buildings separately, they are widespread in the whole campus, right. Now, in this, these are the buildings which I have drawn here as boxes, okay. Maybe it can be a hostel or a academic classroom environment. Like this, we have different buildings, right. So, as part of the mandatory check, we are supposed to have a fire engine or a fire station. So, if I put a fire station here, okay, if I put a fire station in this location, see I have kept a fire station here, right. Suppose some fire accident happens in this building, suppose the fire accident happens in this building, and where is the fire station? It is here. You see the length of this area of this campus, it is very big. So, somebody from here has to make a phone call to this fire station, they have to prepare themselves, anyhow they are ready, but at least it will take some time, a phone call should go, they should start and they should reach here, they should reach here to stop the fire, okay. But what is happening, it is taking almost 10 minutes for them to come, and you know how much damage happens in the 10 minutes of time, right. It is very difficult, because if I wait 10 minutes, lot of damage will happen, property loss will happen. So, it means the question here is, where do you place the fire station, where do you place the fire station such that it is easily reachable. What could be one solution we can do? One solution could be, you will say place it at center, instead of here you may say place it at center, let the fire station be in this location. But if I again still, if there is some building here or some building at this corner, and even though this seems that it is near, it seems it is very near, but there may not be a direct path to this, maybe we have to come this way and go, then reach this way and only reach this way, might be that is the only way we have. We all experience this, right, there is no direct path to everything, we have different roads, so you have to come either in this way or some other way you have to come it out. So, for this building, in this example you think, this is the only way I have to reach from here to here, right. It will take again so much of time, maybe not 10 minutes, but again maybe kind of 7 minutes of time, right. So, it is a problem. I am unable to reach, I am unable to place this fire station even in center, because because sometimes the location, there may not be any path from the fire station to the building. The other alternative could be increasing number of fire stations. So, put one fire station here, put one fire station here, another one here, another one here, another one here. But we do not have that much budget or facility to host 5 different fire stations, keeping in mind the probability of some fire accident happening. So, why, when the fire accident happening is very less, why do I need to have 5 fire stations? Again, that is a problem, right. So, what we can do here is, the criteria here is place the fire station place the fire station such a way that from any building, from the fire station to buildings, it should be the fire station, the fire engine should reach within 5 minutes. That is the criteria. It should reach within 5 minutes. It means maybe I can have some 3 fire stations. I can have 3 fire stations instead of 5, where I can place it one here so that everything is reachable in 5 minutes. Then I can have another one here, somewhere here, so that it is reachable in 5 minutes to all the buildings, right. So, you see what I am trying to do here, I am trying to make those buildings as some nodes like this. I am trying to make those buildings as some nodes, and the route, if there is a road from this building to this building, I will draw a line. Okay, I will draw a line. If there is a road from this building to this building, I will draw a line. Okay, if there is no road here, so I have to come here and then go here like this. So, you are drawing roads. How are you connecting them? All the buildings I am placing them as dots. I am marking them as dots on a paper, and if there is a road from this building B1 to building B2, if there is a road, I will draw a straight line. If not, I will not draw it, right. So, this is called a graph. This is called a graph. Now, we can convert these kind of problems, placing of fire stations as a graph problem, convert that to a graph. So, you have the roads now. Now, find out what is the time. Maybe this is 3 minutes, this is 2, and this is 5 minutes, and again this is some 3 minutes, this is 5 minutes. Like this, you are having the time taken for traveling from one node to the other node. So, you see, instead of reaching from B1 to B7 and then to B8, which is taking 2 plus 5, 7 minutes, I will go from B1 to B4 and from B4 to B8 directly, because it takes 2 minutes. So, there may be a path, we do not know, right. So, to solve these kind of problems, we convert the real world problem into a graph structure, and then we apply our graph techniques to solve those kind of problems. Okay. So, this is just one application. The other application, let us see different applications of graph theory, right. So, the best thing you understand, right, graphs can be used to model road maps and assignment of jobs to employees of an organization. Okay. Generally, for connecting roads, if you want to, you want to travel from city 1 to city 2, there may be different ways. Go to some, maybe this is Trichy. I am at Trichy here. From Trichy I want to go to Delhi. So, one way, from Trichy you go to Bangalore, from Bangalore you catch the flight. This could be one. Depends on the criteria again. Your criteria is less time. Then from Trichy to Bangalore another one flight, Bangalore to Delhi one flight. If time is not a constraint, but little money constraints, then from Trichy to Bangalore you go by train, and from there you go by flight, or you go from Trichy to Chennai, and from Chennai you catch a flight. Okay. So, this way there can be multiple paths to reach from Trichy to Chennai. So, those kind of problems, if you want to find out the shortest path between two cities, you can list down all the paths as all the cities as the nodes, and all the roads between the cities as the edges. That forms your graph, and then you can apply some graph techniques which we are going to study in this course, and find out the shortest path. Okay, that is one application. Other one, you see, the most used one is determine whether two computers are connected by a communication link using graph models. See, in our labs we have so many systems. You have so many systems like this. Okay. Or maybe I can, we have so many blocks, hostel blocks, residential quarters are there, and academic blocks are there, main building is there, right. The CSG, the computer support group, they want to install Wi-Fi routers. So, where should I place the Wi-Fi routers such that the signal is reachable to all the rooms or hostels? No, in a hostel we know where to put the router such that the signal reaches to all the rooms. So, that can be converted as a graph problem. Okay. So, all these, there are so many applications. So, whether two computers are connected or not, whether to find out the shortest path between two cities, okay, find out the shortest path between two different cities, or other things can be seen. Graph can be used to determine whether a circuit can be implemented on a planar circuit board, whether this circuit can be implemented or not, right. It can also be used to distinguish between two chemical compounds with the same molecular formula but different structures. All these are possible. We are going to solve all these problems. We are going to see how, see this question you see, we have to find out whether the two chemical compounds are having same molecular formula or not. Though they have same molecular formula and different structures, are they both same or not? Those things can be verified using graph data structure, right? So there are so many applications of graph. Okay, so we will learn the basics of graph theory. We will study some theoretical concepts and then we will go for the problems. So definition of a graph, right? A graph G V comma E consists of V, that is sets, non-empty set of vertices, and E set of edges. Okay, here V represents set of vertices and E represents set of edges, right? So each edge has either one or two vertices associated, and they are called as endpoints. Means if I have a node 1 N1, another node N2, N1 N2 are the vertices, and this is edge E1. E1 is an edge here, right? So this N1 N2 are called endpoints for this edge E1. For this edge E1, N1 N2 are called the endpoints, right? Then a graph with infinite vertex set is called infinite graph. A graph with finite is called finite graph. Means finite number of vertex and finite edge set. Finite number of vertices and finite number of finite number of vertices means obviously it is finite number of edges. So those kind of graph is called finite graph. Why I am saying this? Because when we give definition, we have to clearly state whether it is a finite graph or not. Okay, so when we see different theorems in graph theory, we will be always quoting, assume let G be a finite graph, means it has a limited number of edges and vertices. Okay, see this example here. So this is some different cities in USA, right? So how they are connected with each other. You see the road network of different cities is shown like this as a graph. Okay, so to reach Denver from San Francisco, either you can go to Los Angeles and come here, or you can directly come here. So you will see different paths here. Here also you see from Chicago to New York, I have different paths. I can either go to Detroit and come here, or Washington and come here, right? So this is a simple example of a graph which consists of vertices and edges. Depending on the problem, that vertices may vary and the edge meaning of the edge may vary. We are going to see lot of terminology here. Next one is simple graph. What is a simple graph? A graph which does not have multiple edges. A graph in which each edge connects two different vertices, where no two edges connect the same pair of vertices. Meaning, if you see here, from Denver to Chicago, I have only one edge. From Denver to Chicago, I have only one edge, E1, that's it. Okay, there is no other extra edge here. So these kind of graphs is called simple graph, meaning between two vertices V1, V2 or Vi, Vj, if there is only one edge, using these two V1 and Vi and Vj, any vertices, if there is only one edge, then we say it's a simple graph. But what is the other case? If you have multiple edges, see here between Denver and Chicago, I have three separate routes. In this graph, if you observe here, right? It means between two vertices V1 and V2, there are multiple edges. Then that kind of graph is called as multigraph. It is called as multigraph. Okay, simple graph, multigraph. Next terminology, right? Loops. Sometimes we have to connect to itself. Okay, maybe when you are testing something, how that link is working or not. See, sometimes a communication link connects to a data center with itself. From a data center, I am taking a LAN cable, connecting it back to it to test whether the data is flowing and coming back to me or not. Okay, so when you have that kind of edges from if it connects back to the same vertex, those things are called loops. Okay, such edges are called as loops. If you see here, there is an self loop. From Denver, I have a self loop. So these are called loops. Okay. Now, graphs that include loops and multiple edges. Graphs that include loops and multiple edges are called as pseudographs. Okay. So again, let's recall, simple graph means between two vertices v1, v2 there is only one edge. Multigraph means between two vertices v1, v2 there are multiple edges. Okay, what is pseudograph? In a graph where there are multiple edges as well as loops, that kind of a graph is called as pseudograph. See, this is a pseudograph. Why? There are multiple edges and there are self loops. So this graph is called a pseudograph. Next concept, directed and directed graph or undirected graphs. What is this different flavor of directed and undirected? Directed graph or digraph. Okay, it contains set of directed edges. In this case, if you see there, or in this example, if you see there is no direction here, it indicates that from San Francisco to Denver there is a road, from Denver to San Francisco there is a road. There is no direction here, but there exists a special kind of graph because for some problems we don't have a return back. We one way, two way traffic, you know, right? One way traffic means it goes only in one way. We cannot come back in the same way. So in a city itself, you want to find out the shortest path, and there are so many one ways and two ways. Then you have to deal with the directed graphs because there exists some direction, right? So if there are set of directed edges, then we say that graph is called digraph or a directed graph. See here, from San Francisco to Denver, I have a direction, arrow mark is there on the path. These kind of graphs are called as directed graph. Okay. Again the same thing, if it has no loops and no multiple edges, then it is called simple directed graph. If it has no loop, no multiple edges and it is directed, then we say it is called simple directed graph. Or otherwise, a graph which contains everything, loops, multiple edges and direction, and undirected, right? We will see that. So a graph with both directed and undirected edges are called mixed graph. A graph with both directed and undirected are called as mixed graphs. Okay. So if there is a graph which contains everything, it's a pseudograph. It's a pseudograph. So let's summarize what we have seen till now, the different terminologies what we have studied here. So first one, simple graph. Simple graph is undirected and it has no multiple edges and no loops. Next, multigraph. It is also undirected, but it has multiple edges and no loops. It has only multiple edges. Then it's a multigraph. Then pseudograph. Pseudograph means it is undirected and it contains multiple edges. It contains loops. Multiple edges and loops both exist. Then comes simple directed graph. Again, in that simple directed graph, it is directed. Okay, the name itself says directed. It is directed. It has no multiple edges, no loops. Directed multigraph means it is directed. It has loops. It has multiple edges. Mixed graph means it is both directed and undirected. It can have multiple edges. It can have loops. So combination of everything, loops, multiple edges, directed, undirected, everything together means that's a mixed graph. Okay. So these are few terminologies about graph theory. We have so many other concepts. We will be seeing that in the next video. Thank you.